Students, today we are going to understand the calculation of random and systematic error. So for today, the topic is calculation of a random error and calculation of a systematic error. Now, first of all, calculation of a systematic error. Now, to calculate systematic error in a given data, the method is that systematic error is given by, we have a formula for that. Systematic error will always be equal to the average of the data values. That is, we can call the average value minus the actual value. So if we subtract actual value from the average value, then we'll achieve the systematic error. For example, actual value of G on the earth is accepted to be, the value of G that we accept on the surface of the earth is generally 9.81 meter per second square. This is the actual value of G that we accept on the surface of the earth. Now, in an experiment, the values of G achieved were 7 meter per second square, 8 meter per second square, 9 meter per second square. Now the question is, calculate the systematic error. Now this is the question. Now the first step would be, you need to calculate the average of the data that you collected. Now the average value of G would be, as you see, it would be 7 plus 8 plus 9 over 3. So this would be 8 meter per second square. So the average value of G is 8 meter per second square. Now, according to formula, the systematic error would be the average value of G. This formula is always applicable. Subtract the actual value from the average value, and then you will get the systematic error. Here you see the average value is 8, the actual value is 9 point, you see it is 9.81 or 9.8 meter per second square. Now the answer would be 1.81 meter per second square. If you round it off to one significant figure, then it would be 2 meter per second square. The reason for this rounding off is that decimal points in 8 are not given. So you'll follow the least precise data when you are subtracting. So 1.81 can be written as 2 meter per second square. And this is a negative systematic error. It is negative. Why it is negative? Because the actual value is bigger than the average value. So this is the method to calculate the systematic error in a given experiment. Now what about random error? Calculating random error. No method to calculate the random error. To calculate the random error, you must know that random error in an experiment is generally plus minus mean deviation. So the random error is equal to plus minus the mean deviation. Now to calculate the random error in the given experiment or in some other experiment, you have to calculate the mean deviation. What is the mean deviation? Basically, calculate magnitude of difference of every individual reading with the average. Calculate the magnitude of difference of every individual reading with the average, and then calculate the average of these deviations. That would be the mean deviation, and then the random error would be equal to plus minus mean deviation. Let's suppose you perform an experiment in which the readings are, you perform an experiment in which the readings are 10, 12, 14, 16, and 18. Here you see the average is 14. Now the average value is 14 and the readings are, you see 10, 12, 14, 16, and 18. Now to calculate the random error, random error, the first step is to calculate the deviation of the readings from the average. Now you see the readings are, we are taking simple values to understand the concept. Basically, the data that we are taking is very simple so that we must be able to understand the concept. The readings were, you see, they were, here the readings were 10, 12, 14, 16, and 18. The average was, you see, it was 14. Now let's calculate the deviation or the difference of every individual reading from the average. First of all, the difference between 10 and 14 is 4. The difference between 12 and 14 is 2. The difference between 14 and 14 is 0. The difference between 16 and 14 is 2. The difference between 18 and 14 is 4. Now these are the deviations. These are the deviations. Now let's calculate the average value of these deviations. That is called mean deviation. This is the method to calculate random error in a reading. Now it is 4 plus 2 plus 0 plus 2 plus 4. There are 5 values in total. So sum of values over number of values will give us mean, and this would be 12 over 5. 12 over 5 is, you see, it is 2.4. So the mean deviation is 2.4. Now, random uncertainty is written as a plus minus, and it is written up to one significant figure. So this 2.4, if it is written up to one significant figure, then it would become, random uncertainties are to be written in one significant figure. This mean deviation is to be rounded off up to one significant figure, that would become 2. Now the random uncertainty in the given experiment would become, this random uncertainty would become plus minus 2. So the concept of random uncertainty is that you need to calculate the mean deviation, and the mean deviation in an experiment would be equal to the random uncertainty. Just for example, let's solve another example. You see, while calculating random uncertainty, the actual value is not needed. You calculate a quantity L that was 20, 21, 22 centimeter. These are the readings. These are the readings. Now, if examiner asks you to calculate random uncertainty. Now the examiner asks you to calculate the random uncertainty. First of all, you need to calculate the average. The average of this data would be 20 plus 21 plus 22, and you see there are 3 values. The answer would be 21 centimeter. Now you need to calculate the mean deviation. Now you need to calculate the mean deviation. The mean or average deviation of the readings from the average would be, this is 20, 21, and this is 22. Now you see your average is 21. Now let's calculate the, see the average is 21, and let's calculate the deviations. 1, 0, and this is 1. These are the, this is average, and then you have these deviations. Now you calculated the deviation between the average and the readings, individual readings and the average. Now you need to calculate the mean deviation. Here the mean deviation would be, as you see, it would be 1 plus 0 plus 1 over 3. So it would be 2 over 3, and as you see, 2 over 3 is 0.67. 2 over 3 is 0.67. Now one thing, we have to write it up to one significant figure. In one significant figure, if you round it off, it would become 0.7. Now the random uncertainty in the given experiment is equal to plus minus 0.7. So basically calculate the average, calculate the differences of individual readings with the average, that is called deviations. Then calculate the average of deviations, that is called the mean deviation. And then round the mean deviation up to one significant figure. Mean deviation written up to one significant figure with plus minus sign will represent the random uncertainty. This was calculating random uncertainty in a reading. Now let's move on. How will you calculate how will you calculating random uncertainty in a measurement? This topic is called compounding errors. In your syllabus, the topic is called compounding errors. Basically, this topic is about, previously we understood how to calculate uncertainties in raw data. The readings were there and we calculated the systematic error and random error in the given raw data. Now you have some values of some quantities and you add them, subtract them, multiply them, divide them, or you power a certain value to find an answer. What would be the uncertainty in the answer if the uncertainties in the individual values are given? Basically, the topic is about calculating uncertainty in the answer of addition, in the answer of addition, subtraction, multiplication, division, multiplication, division, and power. And one thing, we always correct the systematic error, and the random uncertainty is there that will progress, that will move on, that will continue. So you should know that we never calculate systematic error in plus, minus, multiplication, division, because the systematic error is already corrected. When you calculate a reading, you always correct the systematic error. It is not to be continued. So we must say that systematic errors are always corrected in the readings, and they are not to be continued in the answers. So you correct systematic errors. There is no need to understand the method of calculation of the systematic error in plus, minus, product, and division, because you correct them at the stage of reading. They are the random uncertainties which are to be calculated. Random uncertainties, since they have plus minus sign, they cannot be corrected. Random uncertainties are to be calculated in plus, minus, product, and division, as they cannot be corrected. So at the stage of reading, the systematic errors are already compensated or corrected. Just for example, if you have a negative systematic error, then you add it for the correction. And if you have a positive systematic error, you subtract it for the correction. While random uncertainties, they have plus minus sign, they cannot be corrected, hence they are calculated in the answers. Now, to calculate the random uncertainty in the answer of a calculation, you should know that random uncertainty in the answer of any calculation will be equal to, should know that it would be equal to possible range of answer whole over 2. So it is half of the range of the answer. So random uncertainty. Now, what is range? Range is basically the maximum possible answer minus the minimum possible answer. So the range is maximum minus minimum, the highest possible value. So to calculate the random uncertainty, first you calculate the highest possible value, then you calculate the lowest possible value, and then half of that is the random uncertainty with a sign of plus minus. So in simple words, we can say that random uncertainty is actually the maximum possible value minus the minimum possible value whole over 2. And the sign would be plus minus. So random uncertainty in the answer of a calculation would be the maximum possible answer minus the minimum possible answer over 2. Now let's solve an example for that. Let's solve an example for this concept. For example, you are given with length that is 10 plus minus 1 centimeter. You are given with width that is 5 plus minus 2 centimeters. So these two values are given. Calculate random uncertainty in the area. Calculate random uncertainty in the area. Now you see, area is equal to length into width. Now you see, area is equal to length into width. To calculate random uncertainty in the area, we will represent random uncertainty by delta A. Delta A is random uncertainty in area. To calculate random uncertainty in area, first you need to calculate the maximum possible value of area. Then you need to calculate the minimum possible value of area. Then you need to calculate their difference, that is called range, and half of that range will represent the random uncertainty in the area. Now you see, if we calculate this random uncertainty, it would be, first of all, you need to calculate a maximum. Area would be maximum when length is maximum and width is also maximum. So if we multiply maximum length with maximum width, it would be the maximum area. So as a result, the maximum value of length is 11. The maximum value of width is 7. So the answer would be 77 centimeter square. So this is the maximum value of area. Then we need to calculate the minimum value of area. That would be length minimum and minimum width. The minimum value of length is, as you see, it is 9. The minimum value of width is, as you see, it is 3. So 10 minus 1, 9, and 5 minus 2, 3. It would be 27 centimeter square. Now the error in the answer for area would be 77 maximum value minus 27 minimum value whole over 2. So it would be 50 over 2 and the answer would be 25. But one thing, random uncertainties are always written up to one significant figure. Delta A, that is plus minus 25, should be written up to one significant figure, and in one significant figure it would become 30. You must remember that random uncertainties are always written up to one significant figure. Now in this example, as you see, two values were given. One of them was length and the other value was of width. You are given with length and you are given with width. Question was calculate random uncertainty in area, that is product of length and width. Now you see, to calculate random uncertainty in the area, you need to calculate the maximum area, then the minimum area, then maximum minus minimum would be the range. And if you divide that by 2, that would give the random uncertainty in the area. And the answer was 25, but you cannot write it up to two significant figures. Hence, it was written up to one significant figures, that is plus minus 30 centimeters square. So this is the answer for random uncertainty in the area. Students, from here we will start tomorrow, inshallah. Take care. Health wishes. Khuda Hafiz.